Okay, so I hope the first thing I did with this, which is a little bit different, rather than giving them to you all at the end, I have divided this up into your different learning goals. We won't get through all of these today, I don't think, but we will probably either tomorrow or Monday. And I'm going to, like when we get through one set that I give you, that's when we'll quiz. We'll have about 3 quizzes this unit, and then you'll have those before we have the big test. There's a lot of new stuff in this unit. A lot of rules that you have to remember, and we are going to get our formulas for acids down in this unit. But basically this is all about solutions and ions in solution and how they behave. So this is the chapter where now you're going to be able to say, oh yeah, you're going to predict that a precipitate will form. You're going to be able to figure out what's solid, what's aqueous, what's liquid, all of those things. So let's do a little bit of review and see what you can tell me about these things. If I ask you to define, give me a good definition of a solution, concise as you can be, what would you tell me?
Something that solves a problem.
Nick?
A homogeneous mixture.
Good. Homogeneous mixture.
That's all I got.
That is absolutely correct. What are the components of a solution?
Solvent and the solute.
Good. Solvent. Solute. Now this is a little different. We always think, and it's true, but this is a different way to think of it. We always think of the solvent kind of as the liquid part, the part that does the dissolving. Actually, it is defined as substance present in the greatest abundance. Which when we're working in lab, we're working with different molarities of chemicals, our solvent is our water. The solute then would be all other substances present in solution. When water is the solvent, that's when we use our little AQ. So before we start all of this stuff and before we move into lab with our titrations and our precipitate reactions and things, yes, you will learn how to titrate this unit. That's a lot of fun. Some people are really good at it and some people are not. We'll see where you fall. So depending upon the chemical that you're dealing with and how it is bonded, it's going to behave differently in water. And when you did Chem 1, we talked about this a little bit. So we're just going to go through my compounds here. If I have an ionic compound, do you remember from Chem 1, do ionic compounds most often dissolve in water or not? They what? They generally do. Good. So I would say that is called dissociation when they dissolve. And I would say that the H2O surrounds and separates the ions. Then I have to look at the flip side. A molecular compound. They behave differently than our ionic compounds. We've already talked about that in multiple ways. So a molecular compound, I can say that it will interact with water. But most do not dissociate. So they might interact with the water, but they don't completely come apart. So they behave differently in that way. I can say that all substances that dissolve do so by what is called solvation. Which is the surrounding, surrounding of solute by solvent. When I think about these things, like when I think about dissociation, I can separate things into really two big categories. I can have something that I call an electrolyte. This would be a substance that dissociates in water. It dissolves into ions. So an electrolyte is an ionic compound. It dissolves and it forms individual electrolytes. So any ionic compound can be called an electrolyte. If I'm not an electrolyte, then I'm called a non-electrolyte. They may perhaps, I'm going to say, dissolve in water. And they might not. But even if they dissolve, they do not dissociate into ions. So most likely, what kind of compound is going to be a non-electrolyte? Molecular. So think of that with your non-electrolytes. Then we have to think about what kind of a molecular compound, but we'll get there. So let's make a little table. Let's say ionic molecular strong electrolyte, weak electrolyte, non-electrolyte, so when I look at this ionic and strong electrolyte, what would I put in that box, do you think? Some, none, all, most, all. Good. But I would say some are stronger than others. We will see a difference. I did get some new probes this year. Did we use the little conductivity meters in Chem 1? I thought we did, but I think I got some better ones for this year. Weak electrolyte. Would any ionic compound be a weak electrolyte?
Yeah. If it's strong, it can also be.
What?
If it's strong, it can also be. All of them are. I guess they got.
If it's strong enough, it can also be.
Are you wanting to have a gradient of strength? Is that what you're talking about, Nick?
So if it's strong and it passes
Like-
weak, that means it's also weak and strong.
I would say no.
They're all strong. Some are just stronger than others. Okay? So I would say, what would you say, Ellie? None. How about non-electrolytes? Nick? None. Now, here's where it gets just a little tricky and you have to think it through. When I have molecular compounds, there are some that are strong electrolytes. See if you can give me, or see if you can think of what that might possibly be. What do you think?
An acid?
Yes, good. Strong acids. What about a weak electrolyte? If I'm not a strong acid, what kind of acid might I be?
A weak acid?
Yes, I could be a weak acid. I could also be a weak base, and over here I could put a strong base. Because if you think about where do your strong bases come from? The hydroxide paired with what two groups? What's the name of group one? Alkali metals and alkaline earth metals. My group 1, group 2. So, which also form strong cations. So really, it's a base formed of a hydroxide ion and a metal cation. It becomes a molecular compound. So I can put my weak bases here too. If I'm not an acid or a base, but I'm molecular, then I'm going to be a non-electrolyte. So this would be all other compounds. And then we're going to write something in up here. Strong electrolyte, we'll say completely, can you guys see that? Completely dissolves. Weak electrolyte, partially dissolves. And this one we're just going to write does not dissolve. Do you remember from Chem 1 we did the lab about ceramic glaze? Did I do that with you guys?
Yeah.
Do you remember what molecular compound dissolved in water? Not really, really cold water though. What will like if you go to the restaurant and you get some iced tea, but it's that you order sweet tea and they're like, we don't have sweet tea, we only have unsweet tea. But we'll bring you some sugar. Does your sugar dissolve in iced tea very well? Do you know? No, it doesn't. It has to be at least room temperature water. But that's an example of a molecular compound that will dissolve in water, but it's not ionic. So somewhere I thought I had a picture. Okay, so then let's look at this. I'll show you something else. If I have a strong electrolyte, so if I have complete dissociation, I have a strong electrolyte, I can write what's called an ionic equation. And we'll just start with something simple. Now, we said that my strong acids and strong bases could be strong electrolytes, so let's use one that's an acid. Let's use hydrochloric acid. What's my formula for hydrochloric acid? HCl. So let's start with HCl, which is aqueous. And it will break into its parts or its ions of H plus Cl minus. And these would both be aqueous. That is what you would have in solution with water. If I had, I could do the same thing with sodium chloride, but then if I look at something like methanol, this could be my sodium chloride. And as it breaks apart, I've got my sodium, my chloride, they break into pieces, but over here's methanol, which is a non-electrolyte, strong molecular substance, and it won't dissociate. So pay attention if you're given, you know how sometimes I give you the pictures and you have to figure out what's going on in the pictures. Look to see what's happening to the molecules or to the compound. Is it breaking apart or not? Let's look at a weak electrolyte. Partially dissociates. If I have a weak electrolyte and it partially dissociates, its chemical equation will indicate a state of what we call chemical equilibrium. And you should know the symbol for that, where things are going into and out of solution at an equal rate. Do you remember what that looks like? Yeah, good. So let's say I have some acetic acid. This is acetic acid. With its most common formula. And it will be aqueous. And I'm going to show you some other ways it can be written. Then I would show my arrow, like Ellie just said. And on the other side, I would show my H plus being aqueous, my C, H3COO, also being aqueous. This CH3 is called a methyl group, and the C OHH is a carboxyl group. And that one comes into play a lot in organic. Sometimes acetic acid is also written as C2H4O2 or CH3CO2. And this, again, is a weak acid. So you should understand now, anytime you see this arrow, oh, this is in chemical equilibrium, these guys are coming into or out of solution at the rate we're going into solution, that tells me I have a weak electrolyte. Now, all these things have been aqueous, but you know from all the different experiments that we've done, things aren't always aqueous. They might be solid. We might get a solid, the formation of a precipitate. We might get water as in liquid form or gas. So how are you going to figure out what is soluble and what is not? We have something called the solubility rules. And that's what your little card is for. These are rules you're going to have to know. So I'm telling you today, so you've got a while to get them in your brain. We're going to divide it like this. Soluble, ionic compounds. And then over here we're going to say important, and these are the things you really have to remember, important exceptions. And I'm going to say compounds containing. We'll start with this one, NO3 minus. What ion is that? NO3 1 minus. Good. Nitrate. Nitrate is a or all nitrates are soluble. So there are no, or I'll write the word none there. So if you see nitrate attached to anything, you know it's aqueous, it's a solution. What ion is that? CH3COO minus, what? Acetate. That's your other one that has absolutely no exceptions. And I'm giving you the big ones, the ones that I expect you to know. If there's some oddity or something that's not as common, you would be given that with the question. Cl minus, my chloride ion, creates soluble ionic compounds except for when it is with silver, mercury 1, or lead 2. What'd you say, Nick? Nick? Br minus. Same thing. Silver, mercury, lead. What comes after bromine as I move down the halogens? Do you know? Cl, Br, iodide. Good. So my I minus. Guess what? Same thing. Whoops, I forgot my plus. Silver, mercury, lead. So, those three are together on the periodic table. If you can remember one, you know all three. The other one that we're going to deal with, that I will use, is SO4 2 minus, which is what? The sulfate ion. Good. It has some exceptions with strontium, barium, mercury again, and lead too. So these things, you have to look at it and go, is it an ionic compound? And then you have to see if it contains any of these, and then you have to use your rule. And we'll do a couple of examples. Let's look at the insoluble ones. Flip it back, flip it back. Flip it back.
Well, if it's the mercury 2 ion, will that also like not react?
Not necessarily. That would be something that you would have to have more information about.
Okay, so it's just
Yeah.
okay.
This is true always.
Okay.
Okay, can I move it now? Okay, let's look at insoluble. And these are things, the other ones were things they're always soluble except for when they're with this. These are things that are always insoluble except for when they're in the compound I'm going to tell you about. Okay, we'll do compounds containing. All right, let's start with this one. S2 minus, your sulfide ion. So anything with sulfide is insoluble except for if it's with ammonium or alkali metal cations. Of Ca, Sr, and barium. So unless it's with something listed right here, it forms an insoluble compound. Okay, the next one I want to talk about is carbonite. What is the chemical formula for carbonite? What'd you say? Good job. CO2 minus. So, again, important exceptions. Ammonium pops up again. And then I will say all alkali metal cations. Next one, phosphate. What's the polyatomic ion phosphate? PO43 minus. Good. Again, exception is ammonium. And all alkali metal cations. So there's two that are the same. And then our last one we're going to worry about is hydroxide. Chemical formula is OH minus. Good. Again, ammonium shows up. So that's nice. You know, that's true for all of them. Ammonium, calcium. So we've got some specific alkali metal cations. And barium. So these are not too hateful. They're not too hard to remember. We are going to quiz over just the solubility rules, just what we just covered on Monday. Yeah, today's Thursday, right? Monday. Maybe take you 5 minutes. I mean, it's just this. You're not going to even have to do anything with them, but you've got to get them in your brain. They're kind of like the ions. You have to have them. So when do these become important? You have to be able to figure out your precipitate reactions. If it says, this reacts with this, tell me what I get. You have to be able to figure out, is there a precipitate formed? We're all good on what a precipitate is, right? We don't need to go over that again. Okay. So when I'm thinking about that, the first thing I should do is look at the ions present. Then I'm going to look and I'm going to kind of figure out the cation anion combination. So I'm going to kind of predict the other side of the equation. And then I want to decide, are any products insoluble? Those are the ones that would get the S behind them. So I'm going to give you one to try. Let me give you a reaction. Let's have magnesium nitrate plus sodium hydroxide yields, and I want you to predict products, balance equation, give state of products with the use of your solubility rules. So I'm going to give you like 3 minutes to do that. Pick your stuff up, go to your lab station, talk to your partner about it. Be sure your end equation is balanced. We're trying to get this one done before the bell. Oh, Skylar's partnerless. Join a group, Skylar. What should be following the sodium hydroxide on the reactant side? Are sodium and hydroxide going to be a soluble or an insoluble? Yeah, so I should have what behind it? I should have AQ. I left it off. You're not always even given the states of the reactants. Sometimes you have to figure them out. So create your other side of the reaction. Make sure it's a neutral compound, a neutral ionic compound.
Students in problem solving groups.
Got it already? You got it balanced? Okay. When you're done, come back. So when you have it figured out, come back to your desk and we'll talk through it. Okay. Raise your hand if you feel pretty solid, like you got the products or the reactant products correct, based upon the. Okay, Ellie, come up here and write the products in for me. And then we'll let them tell you if you're correct. Yeah, what'd you get? Tell me what you got
On here or on here?
on the white paper, so everybody can see if you're right.
Okay. Balance of 2 or
Nope, we'll let somebody else put the balance up.
okay.
We'll have some fun.
And then when we find the balance,
Okay, do you guys agree with her? Are those the correct products? Okay, who has the state after the product written down?
oh, I didn't write it down.
Okay, Nick, come up and write legibly. Legibly, you can do it.
No promise I'm correct though.
Do you agree with him?
Is that an S?
That's an yes.
Solid magnesium hydroxide, yes. Aqueous sodium nitrate. Okay, Jason, go up there and balance it.
Mrs. When you're labeling the products, could you say, like, liquid is aqueous, or does it have
No,
to be
you
aqueous?
only use liquid, normally with water.
Okay,
Aqueous tells me it's a solution.
okay, okay.
Liquid doesn't tell me it's a solution, it tells me it's a pure substance.
What's that?
Is she right? What do you think? Yeah, good job, guys. All right, I'm gonna stop there because it's almost bell. I put round 1 work up here on the board. I also put it on Google Classroom for you. It will not be due until Wednesday. We're gonna continue notes tomorrow and Monday, and I'll add a little bit more to it, and then it'll all be due on Wednesday. It is 155-ish. I think I put the page on Google Classroom. Oh, I need to stop this.